Good morning, girls. Now, children, you know we have completed chapter gravitation. The theory part is done, that is still mass and weight. And the later part of the chapter is already deleted, I told you. Now, we have to complete some numericals, some questions from the exercise, that is page number 144. So, as I told you, that 8th and ninth are the questions which you can write in the book itself. That what is the acceleration of the free fall? Acceleration of the free fall will be 9.8 meter per second square. You will just write the value. Then the ninth question says that what do we call the gravitational force between the earth and the object? The answer will be the force of gravity. Now the next question is question number 10. It says that Amit buys few grams of gold at the poles as per the instructions by one of his friends. He hands over the same gold to him at the equator. So the question is, will the friend agree with the weight of gold bought, and if not, why? The question is, Amit buys some quantity of gold at the poles. The same amount of gold or the same quantity of gold is handed over to the person at the equator. So the question is, will the friend agree to the weight of gold? So the answer to this question lies on the topic mass and weight. You all know that mass and weight, right? The mass of any object always remains constant. This I have explained you. This is a constant quantity. But here in this question we are talking about weight, right? Now weight of gold. Now weight of gold in two places. Where? At the poles and at the equator, right? Now Amit is buying the gold at the poles. Okay. Now you all know that weight is given by the formula W is equal to M into G. Yes. Now G is more at poles and less at the equator. Fine. So you know that W is equal to mg is greater at poles. Why? Because we can simply write why, because G is greater over here as compared to the equator. So here G will be less. Now, if you will compare the weight of gold at the poles, definitely the weight of gold will be more. Fine. And when he comes to equator, he hands over the same gold to him at the equator. So what will happen to the weight? The weight will decrease. So the question is, will his friend agree to the weight of gold? So you will write no, because when the weight of gold at the poles will be more and the same gold will weigh less at the equator, because acceleration due to gravity, or you can say the value of g is less at the equator, therefore the weight of the gold will decrease. So you can write in your own words that his friend will not agree to the weight of gold because the weight will decrease at the equator, because the value of g is less as compared to the value of g at the poles. Okay, so I hope this question is clear to you, and you can write in your own words. If there is any query or any doubt, you can ask me. Question number 11. Why will a sheet of paper fall slower than the one which is crumpled into a ball? Now there is one activity given in the book on page number when we were studying free fall. Okay, the activity says that if any two objects fall from the same height, okay, actually if this experiment is conducted in vacuum where there is no air, then both the objects will fall down at the same time. So this activity actually says that why will a sheet of paper fall slower than the one which is crumpled into a ball? So this activity or this, how can I explain this? We will take two objects, uh, 11th, question 11th. One is a sheet of paper, right? This is a sheet of paper, and the same paper, that is another one, it is crumpled into a ball. Now both are coming down from the same height. The question is, why will a sheet of paper fall slower than the one which is crumpled into a ball? You all know that when any object is falling down from a height, it is experiencing air resistance. What is it? It is experiencing air resistance. Okay, what is air resistance? Air friction. Now, air resistance is more where there is greater surface area. So, if you compare these two objects or two surfaces, if you compare, we can say that here the surface area is more. So, therefore, the resistance which is exerted by the air on this particular object will be more, and because air resistance will slower the speed of this paper, so that is why the sheet of paper will fall slower as compared to the one which is crumpled into a ball. I repeat what I said. See, this is a sheet of paper and this is a crumpled ball. Now both of them are falling down from the same height. The question is, why does a piece of paper, this sheet of paper, fall slower as compared to the one which is crumpled into a ball? So we can say that this is because both the objects are experiencing the air resistance. Now air resistance is more in case of the sheet of paper. Why? Because of the greater surface area, right? So therefore, because air resistance is more in this case, and resistance means opposition, friction, okay? Because air resistance is more in the case of sheet of paper, therefore it will take time to come down or fall down on the ground, and therefore we can say that the sheet of paper falls slower as compared to the one which is crumpled into a ball. Okay, so this question, I hope it is clear to you, and this completes your 11th question. Now 12th, gravitational force on the surface of the moon is only 1/6 as strong as the gravitational force on the earth. Now this derivation I had explained you that the gravitational force on the moon is weaker, okay, as compared to the surface of the earth. So what is the weight in newtons? Weight is measured in newtons because weight is a force. I have explained you. What is the weight in newtons of a 10 kg object on the moon and on the earth? So you can read the question once again, that you know that the gravitational force which is on the surface of the moon is less as compared to the gravitational force of the earth. And how much less? It is 1/6. Okay, it is 1/6. Now the question is, what is the weight in Newton of a 10 kg object, okay, on the moon and on the earth? So what will we write? We will write mass of the object, question number 12. Mass of the object 10 kg, right? We have to find the weight of the object. So first we will find the weight of the object on the earth, and then we will divide that weight by 6. That will give us the weight of the object on the moon. Okay, did you follow what I said? Mass is given, we will find the weight of the object. Weight of the object is given by the formula m into g. This is, we are talking about means we are talking of earth. When we will calculate this, we will divide this weight by 6. That will give us the weight of this object on the moon. Okay, so therefore this is equal to 10 into 9.8. Yes, and 9.8 into 10 means 98 Newton. Okay, so this is the weight of this particular object on the earth. Now, weight on moon. Now, weight of the object on the moon is given by weight of the object on the earth divided by 6. So, this we have done in the previous class. So, what we'll do? 98 divided by 6. What will be the answer? 6 ones are 6, 7, 8, 9, 3. 6 6 are 36.36, 2, 6 2s are 12, 6 3s are 18. Okay, so 98 by 6 will give you approximately 16.3 Newton So this is the object's weight on the moon. We can check the division once again. 98 by 6, 6 ones are 6, 3 8, 6 6 are 36, right? 2.0, 6 3s are 18, 2, and so therefore this will continue. So the weight of the object on the moon is 16.3 Newton. So I hope this question is also clear to you. Mass is given, mass will not change. If you are asked to find the mass of the object on the moon, so you will write mass will be same, that will be 10 kg. Remember that. Weight keeps changing, depends on small g, and the mass of the object is always constant. So this is children question number 12. Now question 13 is, a ball is thrown vertically upwards with a velocity of 49 meters per second. Okay, a ball is vertically thrown upwards. In which direction? Upward direction. What velocity? 49 meters per second. You have to calculate the maximum height to which it rises. Okay, and the total time it takes to return to the surface of the earth. So definitely if you are throwing any object on in the upward direction, it will not remain in the same at the same height, it will fall down. So you have to find the total time for that particular ball to go up as well as come down, total time. So let us first first find out in the question what is given to us. Okay, so remember that I told you that whenever an object is thrown up, what value of g is taken, positive or negative, we'll discuss that, and then we'll solve the question. So a ball is thrown vertically upwards with a velocity of 49 meters per second. So let us draw a figure. This is a ground. Okay, a ball is thrown upwards, so going up. Yes, question number 13. What velocity? So u will be 49 meters per second. Correct? This is given to us. Now I told you that v is equal to 0 because at the maximum height, velocity is 0. You know why? I'll explain you again. Because when it is going to a maximum height, it will stop for a fraction of a second and then it will fall down. So therefore at the point where it is stopping, velocity will be 0. Fine? Now acceleration due to gravity, g, since it is going up, acceleration is down, so it will be minus 9.8 meter per second square. So therefore we have all these quantities given. A ball, so let us write u is equal to 49 meters per second, g is equal to minus 9.8 meter per second square. You know why minus? Then v is equal to 0 at the maximum height. Now you have to find h. How will you find h? You know all the three equations of motion. So here we'll apply the third equation. H is equal to v square minus u square upon 2g. What is v square? 0 minus 49 square upon 2 into minus 9.8. Okay. Now, therefore, we have minus 40, h is equal to minus 49 into 49. Minus sign is not in the bracket, so don't put it twice. Only 49 square. And minus 2 into 98 into 10. So I'm removing the decimal and putting a point here. So minus and minus will go. Fine. Here we have 49 ones and 49 twos. 49 into 2 is 98. Yes. Now 2 fives are 10. Okay. And yes. So 49 into 5 divided by 2. 49 into 5 divided by 2. 5 nines are 45. 5 fours are 20. 245 divided by 2. So that will give you how much? 2 ones are 2. 2 twos are 4. 2 twos are 4. And 2 fives are 10. So 122.5 meters is the height up to which the ball reaches. Fine. Now find the time. So I hope this much is clear to you, that the ball is thrown up what velocity is given? 49 meters per second. G is given. G is, we know G. So minus and plus we decide depending on whether the object is thrown up or um, it is dropped down in the downward direction. Then V is equal to 0 at the maximum height. So after calculations we get H is equal to 122.5 meters. Now coming to the time. The total time it takes to reach to the surface of the earth is given by the formula T is equal to B minus U upon G. V is given 0 minus 49 upon minus 9.8. So this will be 490 minus upon 98. So you know why 490? Because I am removing the decimal and putting a point here. So minus sign will be cancelled. So 98 okay, 1 minute. 49 tens and 49 twos. It's 5s. Okay, so T is equal to 5 seconds. So you can check the answer in the book. The answers are given over here. That chapter number. Okay. So now we know that the time taken by the object to go up, right, is 5 seconds. It is also saying to find out the total time. So definitely the total time will be, children, 5 plus 5, which is 10 seconds. So the time taken to go up will be equal to the time taken to come down. So I hope it is clear to you that after calculating the height, you will apply the first equation of motion, that is T is equal to V minus U upon G. Find out the answer for T, you will get 5 seconds. Now this 5 seconds means time taken by the ball to reach to the maximum height. So therefore, total time to go up and come down is equal to 5 plus 5, how much? 10 seconds. So we have first answer height as 122.5 meters and the second answer is 10 seconds. So today, children, I have completed with you these 1, 2, 3, 4, 5, 6 questions. Complete these and in my next video, I will solve another set of questions. Okay? And if you have any doubt in these questions, you can message me and you can ask me. Okay? Thank you and have a good day.